The flawed beast, the Tiger I tank, has gone down in history as one of the most feared machines of World War II. Its very name carried weight across the battlefields of Europe. Allied tank crews who caught sight of its massive 88mm gun often described the encounter as terrifying. To them, the Tiger was a steel predator, thickly armored, brutally armed, and seemingly invincible. But behind that reputation lay a far messier truth. The Tiger was a rushed creation, born from desperation and political pressure, and while it could dominate duels on the battlefield, it carried weaknesses that cost the German army dearly. When it first rolled out in 1942, the Tiger was unlike anything the Allies had faced. It could shrug off the shells of the ubiquitous Sherman, the Valentine, and even the Soviet T-34. At the same time, it could obliterate them with a single, devastating shot. This combination made it the centerpiece of German armored propaganda. But what the films and newsreels didn't show was the logistical nightmare behind the tank. It was a monster not just for the enemy, but for its own crews, mechanics, and supply lines. One of the greatest culprits of this nightmare was its suspension system. German engineers, aiming for innovation and stability, designed the Tiger with an elaborate system of overlapping road wheels. In theory, this was brilliant. With 24 wheels on each side, the tank's incredible weight was spread evenly across the ground. The result was a surprisingly smooth ride for such a heavy vehicle. Crews could march long distances without being rattled to pieces, and the tank performed admirably on firm soil. On paper, it was a triumph of engineering, but in practice, this design was an anchor around the Tiger's neck. The overlapping wheels were a nightmare to build, taking enormous time and resources. In war, speed of production can matter more than brilliance of design, and here the Germans had chosen brilliance over practicality. Every Tiger required painstaking work at the factory, slowing down production lines that were already straining to meet demand. While the Allies churned out Shermans and T-34 seconds in the thousands, the German workshops struggled to push out a fraction of that number. The problems didn't stop once the Tiger left the factory floor. In muddy or frozen conditions, which, on the Eastern Front, were unavoidable, the suspension clogged up with ice and debris. Maintenance became a nightmare. Crews reported spending hours, sometimes entire nights, just trying to replace a single damaged wheel. Imagine doing that in the freezing mud of Russia, under the constant threat of enemy artillery. For a crewman, the tank's suspension turned into a curse as much as a blessing, and here lies one of the most realistic what-ifs of the Tiger's design. If German engineers had chosen a simpler suspension system, one closer to what they already used on other tanks, the Tiger could have been far easier to build and maintain. Fewer parts, faster assembly, less training required for mechanics, and quicker repairs in the field. Replacing a wheel might take an hour instead of half a day. Supply chains would benefit too, since interchangeable parts could be shared across different tank models. Even the overall weight of the tank would drop slightly, giving it a little more mobility. Of course, there were trade-offs. A simpler system meant a rougher ride, more jolts, and greater crew fatigue. The tank would perform a little worse in soft terrain, and long marches would be harsher on the men inside. But compared to the enormous advantages of production speed and battlefield availability, these drawbacks were minor. Germany didn't lose the war because its tanks were uncomfortable. It lost because there simply weren't enough of them. So here's the striking thought. By simplifying something as basic as the suspension, Germany could have doubled or even tripled the number of Tigers available in combat. Imagine entire panzer divisions not just boasting a handful of these beasts, but fielding them in larger numbers, repaired and ready to fight. Would that have changed the outcome of the war? Perhaps not, but it would have made every battle where the Tiger appeared far deadlier for the Allies. The Tiger I was already a legend. With a suspension system that emphasized practicality over perfection, it might have been more than just a legend. It could have been a reliable war machine instead of an over-engineered trophy. Speed of the gun. If the Tiger I was a predator, then its 88mm KUK-36 gun was its fangs. This weapon was terrifyingly accurate, capable of punching through the armor of any Allied tank at ranges where enemy shells simply bounced off the Tiger's hide. On open ground, a Tiger could dominate entire battlefields with a few well-placed shots. But even a predator has weaknesses, and for the Tiger, one of the most glaring was how slowly it could bring that mighty gun to bear. The problem lay in its turret traverse. The hydraulic system that rotated the Tiger's turret was painfully sluggish. At low engine speeds, the kind often used when idling in ambush or creeping forward cautiously, the turret could take nearly a full minute to complete a 360-degree turn. Even under the best conditions, it was far slower than Allied tanks. By comparison, an American Sherman could whip its turret around in seconds. In close combat, those seconds could mean the difference between life and death. Consider what this meant in practice. If an enemy tank appeared suddenly on the flank, a Tiger crew might spot it, but spotting is not the same as shooting. The commander would shout, the gunner would line up the sight, but first, the turret had to grind slowly around, groaning like a rusted gate. In those precious moments, the enemy could already be firing. Against nimble Shermans or fast Soviet T-34 seconds darting through woods and villages, the Tiger's slow traverse was a crippling flaw. Now imagine a different design choice, a stronger, faster hydraulic drive prioritized for speed rather than durability. The technology existed. The Germans already had experience with more responsive traverse systems in other vehicles. If the Tiger's turret could rotate fully in just over 10 seconds, it would instantly jump from being one of the slowest turning turrets of the war to one of the fastest. The benefits would have been enormous. Reaction time is survival in armored warfare. In cities, where enemies appeared suddenly from alleys, or in forests, where threats emerged at close quarters, the Tiger would no longer be a lumbering beast, but a quick-drawing gunfighter. The crew wouldn't need to slam the accelerator just to get the turret moving, which saved fuel and reduced wear on the engine. For commanders, this meant they could focus on tactics rather than wrestling with the machine's limits. The trade-offs were surprisingly small. A more powerful hydraulic unit would add a bit of weight, perhaps increase strain on the system, and demand slightly more maintenance, but compared to the battlefield gains, these drawbacks were minor. The cost increase would have been negligible, especially given the enormous resources already poured into each Tiger. And the psychological impact? Imagine being an Allied tank crew. It was one thing to know that the Tiger's gun was deadly, but slow to respond. There was always a slim chance you could outflank it, get that first shot in, maybe survive. But a Tiger that could swing its turret as fast as a Sherman? That hope vanishes. Facing such a machine would not just be terrifying, it would feel hopeless. This is the kind of change that could have reshaped not just the Tiger's performance, but its reputation. Instead of being known as powerful yet ponderous, it would have become powerful and lightning fast. A true apex predator on the battlefield. With no glaring weakness for enemy tankers to exploit, the Tiger already ruled duels at long range. With rapid turret traverse, it could have ruled close quarters too, transforming from a hunting lion to a coiled panther, fast, lethal, and impossible to outmaneuver. The men inside the beast. It's easy to think of tanks as faceless machines, rolling hunks of steel clashing across the battlefield. But every tank was also a small world of men, 5 cramped souls who ate, slept, fought, and sometimes died inside those iron walls. The Tiger I was no exception. Its legend was built on armor and firepower, but its true performance depended on the endurance of the men who operated it. And here, the Tiger often let its crews down. Post-war evaluations, including those conducted by Allied engineers who crawled inside captured Tigers, often came back with the same verdict: cramped, awkward, and uncomfortable. None of these problems were inevitable. They weren't born of physics or necessity. They were design choices, choices that could have been made differently. Take the hatches, for example. The Tiger's escape routes were narrow and poorly placed. In the chaos of battle, when a tank was struck and seconds meant survival, squeezing through those openings was a nightmare. Many crews never made it out. With just a slight redesign, widening the hatches, adjusting their placement, evacuation could have been faster, smoother, and far more survivable. Then there were the seats and controls. For the gunner and loader, space was tight and fatiguing. The loader in particular was forced to work in awkward positions, muscles straining as he hauled shell after heavy shell into the breach. Over long battles, this wasn't just exhausting, it slowed the tank's rate of fire. A better layout of ammunition racks, easier access, and redesigned seating could have shaved precious seconds off reload times. In a tank duel, seconds are everything. The commander, meanwhile, often had to crane his neck and strain his eyes to scan the battlefield. His periscopes and optics were adequate but poorly positioned. Improved designs could have made his job faster and less tiring, giving him more time to focus on decisions instead of wrestling with limited visibility. Even simple additions like padded seating and shock-dampening fixtures could have made hours-long marches less punishing. For the driver and radio operator, the front compartment was notoriously tight. Instruments and controls were crammed in ways that required practice and muscle memory to manage under stress. With better ergonomics, slightly reconfigured layouts, improved levers and pedals, their work could have been smoother, their reactions sharper, their efficiency higher. And here's the key: none of this required futuristic technology. These were not moonshot innovations. They were practical, small adjustments that could have been implemented with minimal cost and almost no delay. Better padding, larger hatches, improved layouts, things that wouldn't have slowed production lines significantly or drained precious resources. The benefits, on the other hand, would have been profound. Crews could endure longer without fatigue breaking them down. Loaders could push shells faster, drivers could handle the tank more effectively, and commanders could maintain clearer awareness of the fight. Evacuation in emergencies would have been quicker, saving lives that were otherwise lost to design oversight. It's worth remembering that a tank is more than the sum of its steel and weaponry. It is also the endurance of its crew. A tired, cramped, and strained crew cannot perform at peak ability. By ignoring ergonomics, the Tiger's designers essentially built a machine that fought against its own operators. Had these small but vital improvements been made, the Tiger would not just have been a fearsome machine, it would have been a sustainable one. A tank that not only struck fear into its enemies, but also gave its own men a better chance to fight, survive, and fight again. In the end, battles are not only won by armor thickness or gun caliber, but by the men inside who endure the strain of war. And if the Tiger had cared for them just a little better, its legend might have been even greater. Armor, reliability, and the Tiger that could have been. If there was one thing the Tiger I was known for, it was armor. Thick, imposing slabs of steel wrapped around the tank, giving it the aura of invulnerability. In reality, that armor was both a blessing and a curse. It could shrug off most Allied guns when it entered service, but its design relied on brute thickness rather than efficiency. Unlike the Soviet T-34, which made clever use of sloped armor to deflect incoming rounds, the Tiger relied on flat plates. Effective, yes, but heavy and ultimately wasteful. Imagine if the Tiger's designers had gone the extra step and introduced sloped armor. Angling the plates would have instantly increased protection without requiring additional steel. Even the same thickness would force shells to ricochet, giving the Tiger a better chance of surviving head-on encounters against increasingly powerful Allied guns. In theory, thinner angled plates could have reduced the overall weight, easing the strain on its suspension and engine. The Tiger could have remained deadly while becoming leaner and more mobile. But there was a catch, and it was a serious one. Sloped armor required a complete redesign. Factories would need new welding techniques, new layouts, new production lines. And in wartime Germany, time was the one resource they could not afford to waste. A sloped armor Tiger might have been stronger on paper, but it would almost certainly have delayed production by months, if not longer. With the Eastern Front collapsing and Allied forces landing in Italy, such delays could have meant fewer Tigers reaching the battlefield when they were needed most. This was the Tiger's constant dilemma, quality versus quantity. More protection might have saved individual tanks, but if it cut the total number available in half, Germany's armored divisions would be weaker overall. The Tiger was already expensive and slow to produce. Adding sloped armor might have pushed it past the breaking point. Still, it's hard not to imagine how much harder it would have been for an Allied crew to face a Tiger that combined its legendary gun with the deflective genius of the T-34's armor. But armor wasn't the Tiger's only weak spot. Beneath the steel, its mechanical heart had a flaw that every veteran crew knew too well: the final drive. This vital component, which transferred the engine's power to the tracks, was constantly overstrained by the Tiger's sheer bulk. Breakdowns were common, sometimes after only a few hundred kilometers of travel. Repairing the final drive was a nightmare, often requiring the removal of the massive turret just to get at the faulty parts. For crews, it meant endless downtime. For commanders, it meant fewer Tigers in the fight, and yet this was one of the most fixable problems of all. With stronger gears, better bearings, and reinforced housings, the final drive could have been made far more durable. A modular design might have allowed mechanics to swap it out in hours rather than days. The cost would have been slightly higher, the development time perhaps a few months longer, but the gains in reliability would have been priceless. More Tigers would stay in combat instead of waiting for recovery vehicles. More divisions would have tanks ready to fight when it mattered most. When you put all these potential changes together, sloped armor, simplified suspension, faster turret traverse, better crew ergonomics, and a stronger final drive, the Tiger I transforms. It shifts from being a mechanical diva, temperamental and unreliable, into something far more dangerous: a balanced war machine, a tank that could have been built in greater numbers, maintained more easily, operated more effectively, and trusted by the men inside it. Would such a Tiger have changed the course of the war? Probably not. Germany's problems ran deeper than any single weapon. By 1943, it was already fighting a war of attrition it could not win. Allied factories churned out thousands of tanks, while German industry strained to build hundreds. Air superiority slipped away, fuel supplies dwindled, and manpower bled dry. Even a perfected Tiger I could not have solved those grand strategic problems. But on the battlefield, at the human level, the difference would have been immense. Allied crews would have faced not just a terrifying opponent, but a truly reliable one. Fewer Tigers would have broken down, more would have been ready at the front, and every engagement would have been that much deadlier. The myth of the Tiger, already so strong, might have become an even darker reality. In the end, the Tiger I we remember is a paradox, one of the most iconic tanks in history, yet also one of the most flawed. It was a masterpiece of firepower and armor, shackled by its own complexity. And so we're left to wonder, if German engineers had made just a handful of different choices, would the Tiger still be remembered as a legend? Or would it have become something far more dangerous, not just feared, but unstoppable?